Now, with these formulas, it's time for us to calculate the pH or pOH of strong acids and strong bases. And first, let's look at the theory. Now, since we're looking at strong acids and bases, we know that strong acids and bases fully dissociate in water. So the concentration of H plus, concentration of OH minus will be equal to the concentration of a monobasic acid or base, right, such as nitric acid or sodium hydroxide. Likewise, if you're looking at sulfuric acid, looking at barium hydroxide, dibasic acids or bases, the concentration of H plus or OH minus will be twice of the concentration of the acid and base used. One more thing. We have learned that water undergoes autoionization, alright, and it produces its quote-unquote own H plus and OH minus. We need to consider that in our finding for pH and pOH of strong acids and bases. Not all the time, but there is a chance. If the concentration of H plus or OH minus from the acid or base added is lower than the autoionization of water, then we need to consider the concentration of H plus and OH minus from this autoionization of water. Alright, so for example, we have, let's say, room temperature, where we know that the concentration of H plus and OH minus is 10 to the power minus 7. If we have this H plus and OH minus being less than 10 to the power minus 7, then we need to include this as well. Okay, which means that, let's say this is, 10 to the power minus 8, then we need to do 10 to the power minus 8 plus the autoionization of water. Okay, one more thing. pH plus pOH, this equation come out again only at 25 degrees Celsius. If the question never states, assume that we are doing everything in 25 degrees Celsius, our favorite room temperature. Let's begin. First example. Calculate the pH and pOH of 0.2 mole per dm cube of hydrochloric acid. First thing, alright, this is a strong acid giving us hydrogen ions, so not hydroxide ions, so we have H plus equals to 0.200. Because this is greater than the hydrogen ions produced by the autoionization of water, we can ignore that and just calculate pH, which will then give us, if I'm not mistaken, 0.699. Alright, again 3SF, so I don't want to see 69897. pOH, remember, because the question never states, we assume it to be 25 degrees Celsius. And at 25 degrees Celsius, pOH plus pH equals to 14, right? Kw is 10 power minus 14. So pKw is 14. So very simple mathematical manipulation, 14 minus 0.699 would then give us pOH 13.301. Take out the 01, 13.3. Hope you guys got that. Alright, first example, I know, might be a bit unfamiliar, but quite simple. Alright, so second example, if you want to, pause the video, give it a shot, otherwise here we go. Same thing, but now with 1.5 times 10 power minus 5 mole per dm cube of barium hydroxide. Barium hydroxide is quite clearly a base. It is a strong base. So concentration of OH minus equals to 1.5 times 10 power minus 5. However, this is a dibasic base times 2. 3.0 times 10 power minus 5 mole per dm cube. Alright, capital M for mole per dm cube. You shouldn't really use that, that's just for us, but I'm the one presenting, so I want to keep things fast. Alright, so again, 3.0 times 10 power minus 5 mole per dm cube, higher than the concentration of OH minus from the autoionization of water at 25 degrees Celsius, so we can ignore 10 power minus 7, and now we are calculating pOH. We're not calculating pH, alright, something new. We're now applying minus log to OH, hence pOH minus log 3 times 10 power minus 5. And that would then give us 4.5228, 4.52. pH, once again, room temperature, 14 minus 4.52, 9.48. Alright, so few things here. Do not autopilot, alright? You're applying the minus log to OH, not applying the minus log to H, alright? Something new, but with logic, you should be able to get it. Okay, last thing, die basic base, so don't forget to times 2. Easy, right? Example 3, same thing, 1.5 times 10 power minus 8 mole per DMQ of nitric acid instead. Again, experience tells you strong acid give you H+. So H+, consider H+, is 1.5 times 10 power minus 8. The difference is this is lower than 10 power minus 7. The concentration of hydrogen ions produced from the auto-ionization of water. Therefore, we need to consider that now, plus 10 power minus 7. This then gives us 1.15 times 10 power minus 7 mole per dm cube of H plus ions. Now we calculate pH. So that's minus log 1.15 times power minus 7, 6.94. Alright, 6.9393, again 3SF, so 6.94. Room temperature, so 14 minus 6.94, simply 7.06. Okay, so this is the case where you need to consider the concentration of hydrogen ions from the auto-ionization of water. Alright, so that is the end of the first level, and we'll soon be moving on to the second level where we find the pH and pOH, not strong acids, but weak acids and bases as well. But well done to us, we've cleared the first level, we are making good progress in finding a friend. Alright, see you guys next time, and let's get this bread.